In this video, I am going to teach you how to solve rational equations. Now, there are two methods that you can use to solve rational equations. So the first method is that if you have a proportion is simply a statement that two ratios are equal, two fractions that are equal to each other, or two fractions that have the same value. For example, 2 over 4 is the same as 1/2. So this is a proportion, okay, because 1/2 is the same as 2 over 4. And another way to check to see if this is a proportion is to cross multiply. So if you cross multiply, you get 4 equals to 4 because 2 times 2 is 4, and then 4 times 1 is also 4. So that would be another way to check to see if you have a proportion. Okay, so let's take a look at the first example here. Okay, so here I have plus 3 over 3 is 8 over minus 2. Okay, so this is an example of a proportion. Okay, you're finding out what is that make this fraction equals to this fraction. So the fraction on the left is the same as the fractions on the right based on what is, okay? So therefore you have a proportion. So how do you solve proportion? Well, to solve proportion, you would cross multiply and then solve. So I'm going to cross multiply, so that means plus 3 times minus 2. So I have plus 3 times minus 2 is, and then 3 times 8, 24. Okay, so here I have 24. Okay, so first thing I have to do is multiply these two binomials. So distribute the So I have squared, take away 2 and then do the same thing with the 3. Multiply the 3. So I get 3 take away 6, and that is 24. Okay, combine like terms. Negative 2 with positive 3 is going to be 1 and then minus 6 equals to 24. So this equation here is a quadratic equation because of the square. See, this square makes it a quadratic equation. So to solve this equation, you would have to set it equals to 0. And then the easiest way is to try to solve it by factoring. So to set this equals to 0, I would have to minus 24 and then minus 24. Okay, so I have squared plus take away 30 is 0. And then factor the trinomial. So factor this trinomial into two binomials. So I need an times an to get the square. And then my a times c is negative 30, and then my b is 1. So I'm going to need a positive 6 times a negative 5 to make it happen. Factors of negative 30, that when you add those numbers, it comes out to 1. Okay, and then we're going to set each factor equals to 0. So plus 6 is 0. That's going to give me negative 6. And then take away 5 is 0. So this is going to give me 5 when I solve it. And then you have to check it. Now when you're solving rational equations, you always have to check it because, okay, you cannot divide a number by 0. So if your denominator is 0, that would make it undefined. Okay, so you have to plug it in to make sure you don't get 0 at the bottom. So my answers are negative 6 and 5. So if I put 6 in here, I'm okay, right? Because 6 take away 2 is 4. If I put 5 in there, I'm okay because 5 take away 2 is 3. Okay, so those two numbers are good. So my final answers is going to be equals to -6 and +5. Okay, so this is the final answer. Let's take a look at the next one, the next example. So this example, I have 2x minus 3 all over 2 is 3 over x plus 4. Again, this is another example of a proportion. So this fractions on the left is equals to the fractions on the right based on what x is. So we got to solve for x. Okay, so we're going to solve this by cross multiplying. So we're going to take 2x minus 3 times x plus 4. So that's 2x minus 3 times x plus 4 is, and then 2 times 3 is going to give me 6. And then multiply the 2 binomial. So I have 2x times x is 2x squared. And then 2x times 4 is going to give me 8x. And then the same thing with -3, -3 times x, and then -3 times 4. So that would be -3x, take away 12 equals to 6. Okay, collect like terms on the left-hand side. I'm going to end up with 2x squared plus 5x, take away 12 is 6. So again, I have a quadratic equation because of the x squared term. So I'm going to solve it by factoring by setting it equals to 0. So to set it equals to 0, I would have to -6 minus 6. So here I have 2x squared plus 5x, take away 18 is 0. I'm going to see if I can solve this by factoring this trinomial. So using the AC method. So AC is -36. A times C, and then your B is 5. So I have to come up with two numbers, factors of -6, that when I add them, it comes out to 5. So that has to do with 9 and 4, but it's going to be a -4. Okay, so then it'll be x plus 9, and then x minus 4 is 0. Now, because my coefficient is a 2 and not a 1, I'm going to use the slip and slide method. That means I got to divide this by 2 and then divide this by 2. So 2 goes into 9. 2 cannot go into 9. So the 2 is going to go to the front of the x. So it'll be 2x plus 9 is one of the factors. And then here 2 goes into 4 2 times. So that becomes 2. Okay, and then solve for it. I would have to set each factor equals to 0. So this is going to give me -9 over 2. Okay, and this is going to give me 2. Okay, and then always have to check it to make sure you don't have an undefined, meaning cannot have 0 at the bottom. Okay, if I plug -9 over 2 into this x, you can easily tell it's not going to come out to 0. And if I plug +2 into this x, you can tell it's not going to come out to 0. So therefore, these answers are good. Another way to solve rational equations is using an LCD, which is the lowest common denominator. So you would find the LCD and then use the LCD to multiply with all the fractions. This way we'll get rid of all the fractions and then solve the remaining equation. Let's take a look at an example. So this example, I have 4 over 3 take away 7 over n is 1 over 6. Okay, so this is a rational equation and we're solving for n. Now the first way to solve this is to condense this into a proportion. and then cross multiply. But we're not going to do it that way. We're going to do it the second way. So the second way is to find the LCD, which is the lowest common denominator for 3, n, and 6. So what would be the smallest term that 3, n, and 6 can all go into? That is going to be 6n. So 6n is your LCD. You're going to multiply all the fractions by the LCD. So we're going to multiply this by 6n. And then we're going to multiply this by 6n. And then we're going to multiply this by 6n. Okay, so this way it will get rid of all the fractions. So 3 goes into 6n, 2n. And then you're going to take 2n and multiply that with 4. And that is going to give you 8n. Minus n goes into 6n. You're going to be able to cross out the n. So you're left with 6. 6 times 7 is 42. So here 6 goes into 6n, n time. That means you can cross out the 6. So you're left with n, and then n times 1 is going to be 1n, which is just n. By multiplying all the fractions with the LCD, you are able to eliminate the fractions. Okay, as you can see, with this equations right here, 8n minus 42 is n. Okay, you no longer have fractions involved. Okay, so we're going to go ahead and solve this remaining equation. So solve for n, find out what n is. I have an n term on this side, and then I have another n term on this side. So I'm going to get them on the same side. So with minus 8n here to get rid of the positive 8n, and then minus 8n to this side. Okay, so 8n minus 8n is gone, so that add up to 0. So you're left with negative 42 is negative 7n. And then to get the n all by itself, you would have to divide by negative 7. So then I got to divide this by negative 7. Okay, so that turns into a 1. So you're left with n. And then negative 7 goes into negative 42 is 6 times. Okay, so your n is 6. Now, when you're solving rational equations, you always have to check it to make sure, okay, the denominator doesn't come out to 0 when you plug in what n is. Okay, so if I go back, I know my n is 6, so only this one. So if I plug 6 into this n, okay, I end up with 7 over 6, which is not 7 over 0. Okay, so that would be okay. And then I'm okay with the 1 over 6 on this side, because there is no n for me to plug in the 6. Therefore, n equals to 6 is good. Okay, so next example, I have p over p minus 2 plus 2 is 8 over p squared take away 4. So this is a rational equation, and I'm going to solve this by getting rid of the fractions. So to do that, I would have to find the LCD for p minus 2 and p squared minus 4, and then multiply all of the terms by the LCD to get rid of all the fractions. Since I'm working with binomial here, I'm going to need to factor this p squared minus 4 and then compare with the p minus 2 to see what I need for my LCD. So p minus 4 is a difference of 2 perfect square. So I can factor this into p plus 2 times p minus 2. So here I have p minus 2, and then I have p minus 2. So I'm missing a p plus 2. Okay, so my LCD is going to be P plus 2 times P minus 2. So this is what I need for my LCD. After you find your LCD, you are going to use it to multiply with all of the terms of this equation. Okay, so here I'm going to multiply this by P plus 2, P minus 2. So P plus 2 times P minus 2. And then 2 over 1. So the 2 is the same as 2 over 1. Okay, and then I'm going to multiply that by P plus 2 times P minus 2. And then the same thing with the 8 over P squared minus 4. I'm going to multiply that by P plus 2, okay, times P minus 2. I'm going to be able to eliminate this P minus 2 with this P minus 2. So you're left with P times P plus 2. Okay, so here I have a 1, so that means I'm going to have to multiply the 2, okay, with the... Now P plus 2, P minus 2, when I multiply those two binomials, I'll get this. So I'm going to use this for the P plus 2 times P minus 2. So that's going to be P squared minus 4. I'm going to be able to eliminate the P plus 2 with this P plus 2, and then P minus 2 with this P minus 2. So I'm left with 8. Okay, so now I'm able to get rid of all the fractions. So I'm going to solve this remaining equation. I would have to get rid of the parentheses, so distribute the P. So I have P squared plus 2P. Here distribute the 2. So I have 2P squared. Take away 8. And then 8 on the other side. And then combine like terms. I end up with 3P squared plus 2P. Take away 8 is positive 8. Now this equation is a quadratic equation because of the P square. See this P square right here? That makes it a quadratic equation. So I'm going to solve this by factoring. So first thing I need to do is set it equals to 0 by getting rid of the positive 8 on this side. So I have 3P squared plus 2P minus 16 equals to 0. Okay, so I'm going to solve this by factoring. So I'm going to try to factor the 3P squared plus 2P minus 16. So I have to find my AC. A times C is going to be negative 48. And then my B is going to be 2. So I need two numbers multiplied to get negative 48. When I add those two numbers, it comes out to 2. So that would be positive 8 and negative 6. Okay, so here's going to be P plus 8 times P minus 6 equals to 0. And then I would have to divide by 3 because my leading coefficient is a 3 and not a 1. So we'd have to divide this by 3. This is called the slip and slide method. Okay, so 3 cannot go into 8 exactly. So the 3 has to go to the front of P. So that makes it 3P plus 8. And then 3 goes into 6 2 times. So that's going to be P minus 2. Okay, now I'm going to set each factor equals to 0 to solve for it. So here I have 3P plus 8 is 0. Solve this one, I'll get negative 8 over 3. Okay, and then the other one is P minus 2 equals to 0. Solve for P here, I'll get 2. Okay, so my two answers for now is going to be negative 8 over 3 and then positive 2. Okay, since I'm working with rational equation, I always have to check it to make sure I don't get 0 for my denominator when I plug these p back in. So if I plug negative a over 3 for this p, you can easily tell that this is not going to come out to 0. Okay, and then when I plug negative a over 3 here, when I square it minus 4, it's not going to come out to 0. P equals to negative over 3 is good. So that one's good. So now I have to check P is 2 to make sure it's okay. So if I plug 2 in here, oh, there you go. I'm going to get 0. 2 minus 2, as you can see, 2 minus 2, when I plug the 2 in here, it comes out to 0. So that makes it undefined. Okay, you cannot divide a number by 0. Okay, so this one is no good. So P equals to negative a over 3 is the only good solution here. Okay, and then the P equals to 2 is an extraneous solution. Okay, so we're going to look at one more. So this one I have 3c, take away 2, all over c squared, take away 4c. And then I can factor, I'm going to go ahead and factor the c squared minus 4c. So with this, I can pull a c out. Okay, so then I'm left with c minus 4. And then it's equals to c over c minus 4, and then take away 1. Okay, so my LCD here, so here I have c minus 4, I have c minus 4. So I would need a c with this one to make it a c times c minus 4. Okay, so my LCD is going to be c times c minus 4. Okay, so I'm going to take the LCD, use it to multiply with all of the terms. Okay, so I'm going to multiply this by c times c minus 4, and then multiply this by c times c minus 4. Okay, and then same thing here. Okay, times c and then c minus 4. Then when I multiply, I'm able to cross cancel. So I can cancel all of these with all of these. Okay, so you're left with just 3c minus 2. So here I can take out this c minus 4 with this c minus 4. Then I have c times c, which makes it c squared. Okay, and then over here, I have nothing to get rid of the c times c minus 4. So I have to distribute the minus 1, which is the negative 1. So if I distribute the negative 1, I'll get negative c squared plus 4c. Okay, so now I would have to solve this remaining equation, solving for c. So I have 3c minus 2, and then c squared, take away c. Those are gone. It's going to add up to 0 and then bring down to 4c. And then now I have to get c on the same side. So I would have to minus 3c here and then minus 3c over here. So this is gone. Bring down to negative 2. Now 4 take away 3 is 1. So it'll be 1c. So c is going to be negative 2. So this is your answers for now. Okay, and then we have to check it to make sure the denominator doesn't come out to 0 when we plug in negative 2 for c. Alright, so over here I have c squared minus 4c, so I gotta plug my c in here. So c is negative 2, so when I plug negative 2 in for c, negative 2 squared is 4. And then here, 4 times negative 2 is negative 8, which becomes a plus 8. So that would be 12. So that is not 0. So that one's good. And then plug negative 2 in here. So negative 2 take away 4 is negative 6. Okay, and that's not 0. So that one's good. And here I don't have to worry about it because there is no c in the denominator for me to plug in negative 2. Okay, so therefore c equals to negative 2 is good.